Hi guys. See, the main intent of this class was to cover the log functions the school is going over, right? We are a little laggy on that, I felt. So I really wanted to get that done. Can we keep going?
Yes.
Ritik, Niti, Vibha, all of you are in here.
Yeah.
Okay, and Rohan as well. I know we are halfway through the exponential functions. I'm going to take a detour, cover some log functions and go back, okay? I just want to make sure you're aware of doing work with logarithmic functions before they do it in school as well. And that's the intent of this class. 1 second, guys. Just give me a minute. Before I move on to function modeling and all, let me go over the basics that we already studied with the logs. If you're comfortable, then I can keep going. Let me share my screen. Okay. We discussed exponential functions, right? Let's say we have this log base b a. If we have a function of this format, right, equal to a, do we remember how to convert this to exponential functions? Let me put it out as log base b of c is equal to a. I'm going to go over logarithmic functions, take a detour from exponential functions, then move back. Both can be dealt with together. School has already started with logarithmic. So given this, do you remember how to convert it to an exponential exponent? Guys, you have to raise up and say,
Wouldn't
and
it be b to the power a equals c?
b to the power of a equal to c. Here, b is not equal to 0. B is greater than 1. Oh, wow. B is greater than 0. B is not equal to 1. That correctly. B is not equal to 1. 1 second. So here B is, I should rewrite that. B is not greater than, B is not equal to 1. B is not equal to 1. Rohan, are you there? Rohan? Rohan, are you here? Nandini, are you here?
Yes, Priya, I'm here.
Okay. Is he going to?
I am not sure yet. I have sent him a reminder.
Okay.
Yeah, so
Okay.
waiting
Makes
for him to
sense.
join.
Okay. Okay. Makes sense. Okay, let's go ahead and work a few problems out to just revise this and then I'll move on. Okay. How about this? What is the value of this? Guys, you're going to work it out and let me know. Log base 3, log 81 base 3. What is the value of it? You're going to let me know in chats because these all we have covered in algebra 2. If you don't remember only, I'm going to cover that again. See, I wanted to be in. Pratik, Supraji both got it. Nidhi got it. Nitin, do you need help? You can shout out and let me know. Oh, yes, I don't remember. That's fine. But I
I
just
think I
want to
got
know
it.
something.
Is
Okay. I thought it was 4. So see
Oh,
here. Take it as y.
yeah.
3 power of y is 81. Okay, what 3 power of y is 3 power of 3 power of what is 81? 4 is equal to y. Can I move on? Maybe one more, then we can move on. I feel. Let me see. How about maybe one let me give you a harder one. How about this? Log 100. Log 100. What is log 100? Log 100. I'll write out the problem, guys. The second one. You should have your calculators, Amma, with you. It's so important.
Wait, Miss Priya, is it log base 10 100 or like log base 10?
Good question, Ritik. When they give it to you as log, you don't have to worry about the base. Okay. When they give it to you as ln, then the automatic implicitly they mean that this is equal to log base e. Does it make sense? Suppose if they want some other base, right, they will by themselves give you like this. Does it make sense? Ritik, am I making sense?
Yeah.
Okay. Vibha, you got a hang of it, Vibha, now?
Yeah, auntie, I get it.
Can I move on?
Yeah.
Okay. What are they doing in your school, Vibha?
Right now, I think we just finished rationals. We're starting, I think it's logarithms actually.
Oh, okay. Good to know. So how about this? If you have it like this, what are you going to do? Any thoughts? I'll come to this a little later, but any thoughts? Any thoughts, guys, based on what we have studied? It's okay if you don't, but just let me know, right?
Would you rearrange it to like? Would you do log base? Would you split up that value of 25?
Yeah, but that's not going to give you any result, right? Even if you write 5 square, right?
Yeah. So, or you could convert it into an exponential.
You can, yeah, even if you convert it, you're not going to, that is the problem here. Meaning, even if, see, that's what I thought too. Look at it here, equal to y. Now, the thing is, 4 power of y equal to 25, we can never solve this, right? This is one scenario where we would require change of basis. We learned it in algebra 2. We will come back to this in another 15-20 minutes. We need for these questions like this, where we can't see here 4 power of y can never reach 25, right? So we need change of basis formula to solve such logarithmic problems. Okay. I will come back to this. Okay. We'll go step by step. So in a way, you really understand what is logarithm. See the concept, if it is clear, whatever be the question asked, you should be able to tackle is what I'm also thinking. So how about this? What is the difference between a linear scale and a logarithmic scale? Why are we going for a logarithmic scale? Why are we, what is this base 5? What is this base 10? What is this base e? We don't understand any of it, but we have been studying in algebra too, right? So let's understand what are we doing with these bases. Okay. Let's review this. Okay. Okay. Now I've written, meaning there is a table put up. Okay. For each person, the average video length. Okay. Each person is submitting a video. Their video lengths, okay, are given in seconds. If it's a linear scale, right? Meaning linear scale means we are going to, for this, for these values, I'll go with what? Let's say I go with 0, It's going to be too lengthy. Till 10,000 I want, right? Maybe 1,000, 2,000 will go. 1,000, 2,000, 3,000. First understand. Ordinary linear scale will do, right? Why do we want to learn logarithms and exponents? We don't need to at all, right? So this will answer your question. Okay. So here, when you think about it, right? My first point, I will plot for each of these people, okay? The person name I'll plot and then take him as S, B, B, and K, okay? So first is 505, which will be here, a little bit here. And then 830 is also here, okay? And then 1,440 is somewhere here. Kelly is 10,160, he's here. So on a linear scale, see what is going on. Whereas, let me try to bring up a logarithmic scale. What does it mean? Logarithmic scale goes in increments of 10 power, right? So let me try that. Let's try taking 10 power of 0, 10 power of 1, 10 power of 2, 10 power of 3, 10 power of 4, 10 power of 5, 10 power of 6. You don't need so much, right? Now the thing is, the problem is, I'm going to find out log 505. Can one of you please let me know the values? Log 830, log 1440. Can one of you please, you can use your calculator and let me know the values. We're not going to find out. I just want you to understand why we go for it. If one of you, Bhuvnesh, can you help me? Guys, do you have the calculators with you?
Hey, Auntie, do we put it into green mode?
That does not matter, Ma.
Okay. Log 505 is 2.7.
Uh-huh.
Log 830 is 2.92. Log 1440 is 3.16.
Log 10160 is?
1016. It's 4.01.
Okay, so that is enough for now. Now, let's go ahead and plot these values. See, when I want to plot 2.7, right? So I would go ahead with a 2.7 somewhere here, right? 2.7 comes here, 2.92 comes here before 10 power of 3, and 3.16 comes here, and 4.01 comes here. So do you see the distribution? Meaning you're able to see in a linear scale, see how far apart they are. If the values are too big, one is small, one is big, they are so far apart. Whereas a logarithmic scale is able to make you see things in your eye perception better. If the values are so large and so small, they have a big broad range. Do you get what you mean? What I mean now? Let's try to find out. You can even plot it in base 5, 5 power of 0, 5 power of 1, 5. You can plot it and see again in log base 5. In that case, we need to find log base 5 of 505, log base 5 of 830, log base 5 of 1440. If I find this and plot it again, it will all be in your perception, meaning the values you will really be able to see within your eyes, meaning it won't be like crunched up like this one end and the other end. Do you see? In a linear scale this happens, but when you bring it to a logarithmic scale, the perception completely changes and you're able to see them all here within, meaning within your reach. You see? So it brings up a nice clear picture of where we are. So that is why we go in for logarithmic scales. Can I move on? Any questions in here? Any questions in here?
No.
Any questions?
No.
Okay. So now let's find out this one. So this is the main reason why we go with logarithmic scale. So you should be able to given the linear values, you should be able to plot it in a log base 10, log base 5, any scale value. Now, let's see this one. If log 6x, let's see. And you can use your calculators for this. How about, can I rewrite this as a log function? Meaning I would like you to rewrite this as a log function. So the base is always the same. Here in the exponent and the log, the base is always the same. This is called the base. This is called the exponent, right? So if I write this as a logarithmic function, how will I write it? Your exponent will... Guys, do you want me to say, or you already know this?
Can you say it?
Sure. So here, if the base is 16, right? I'll maintain the base in the exponent, in the log 2, this is going to be the base. This 3/4 will transfer in here. Okay. Now log of this one will come here. So this is how you change from exponent to a log function. Remember, the base is always the same between both the functions. The exponent will become your y value. Do you see it?
Yeah.
Perfect, Abhiram. Yeah. So here, let's go ahead and try writing this. We'll do one more to basically understand what we are doing. And then I really want to move on to function modeling with logarithmic functions today. How about this? Abhiram, have you touched semi-log plots? Or Bhuvanesh?
I don't think we did.
Okay, okay.
We just
Okay.
did how to like combine log functions into a single log and like exponentials into a single
Oh, I
exponential.
see. So have you started condensing, expanding
Yeah.
logarithmic function? Okay.
Yeah.
Okay, let's see. Let's see. I'll try to cover most of it. See, because when from algebra to it, that just needs another round of review. Do we want to go ahead and write this as an exponential function? How to write it as an exponential function? The base is always the same. Perfect, Abhiram. Perfect, Vibha. So the base is always the same. If you remember that, then it becomes easy. Ritik, are you able to do? Nidhi, are you able to do, ma?
Oh yeah.
I'm not getting answers from you either. Bhunesh, that seems correct. So 32. At this level, guys, if you're not going to answer, I'm just going to move on. Rohan, I'm not getting your answers. Nitin, I'm not getting your answers. If you didn't know, you can just raise up and say, Auntie, can you do it on the board? That's so easy to say. 32 is the base. 2 power of 5 will be equal to 4. Rohan, the question was, I have written it on the board as well. Write the exponent function. Okay, let's move on. Now let's see this one. How to evaluate each log. How to evaluate this logarithmic function. Can you try this one? When the x value equal to 5, evaluate this function. Yep. Yeah, Nitin, you got it. Ritik, you got it. Rohan, you got it. Abhiram, good. Yep, the next thing I wanted to show you is the good. Bhuvanesh, are you getting it?
Yeah,
Do you want me to wait or can I move on?
I'm about to send it.
Okay, Vibha, how about you? Yes, Vibha, that's right. So now let's discuss the difference between the two. Okay, we have done exponential function to an extent. we know what is a logarithmic function. So let's write x and f of x. Okay. Now here let's consider a function 2 power of x. Okay. Now here I'm going to start with I'll show you the difference in terms of the table first, and then let's see the graph and how do they become. Okay, let's go over this. Okay. So I'm going to evaluate f of x equal to 2 power of x. So let's see few values. So -2, -1, let's start 0, 1, 2, 3. So this one would be 1, 2, 4, 8, 16, and 32. This one minus will be half. Okay, so how will the graph going to be? This is an exponent function, right? So it's going to be -1/2, 0, 1, and then 1 is going to be 2, then 2 is going to be 4. It's going to rise up like anything. 3 is going to be 8. So basically it's going to go like this. This is an exponential function, right? Now, if I start writing the logarithmic function, x f of x, this is going to be log x base 2. So how are we going to write this? When I start writing this, substitute values, like I'm going to have values of half, 1, 2, 3, 4, 1, 2, 4, 8, 16. So substitute in here. Why am I considering these values? Because I'm considering base 2. It's going to be easy for me to calculate. In the calculator, if you evaluate this, log half base 2 will be a -1. Log 1 log 1 base 2. Log 1 is 0 for any base. And then log 2 base 2, that will be a 1. Log 4 base 2 will be a 2. Log 8 base 2 will be a 3. Log 16 base 2 will be a 5. When I do that, when I do this and plot it down here, half will be a -1. So half will be a -1. 1 will be a 0. Okay. And then 2 will be a 1. And then 4 will be a 2. You see what happened here? Here, this is going to be like this. So when you think about it, right, here, graphically, when I plot it, could one of you comprehend what is this?
It's the inverse
It's the inverse. How do you say as the inverse?
because
Meaning
it's reflected over the line y equal x.
y
Yeah.
equal to x. So when the exponent graph, the red color graph is reflected over the line y equal to x, it becomes the logarithmic function. So if this happens, right, in mathematics, right, they are called inverses. So we are clear that the exponent function and the logarithmic function are inverses. This is in the graph, okay? Algebraically, when you think about this, the x and y, x and y, x and y of the exponent function just get interchanged. See, half -1, half -1, 1 comma 0. The domain of the exponent function is the range of the logarithmic function. The range of the logarithmic function is the range of the exponent function is the domain of the logarithmic function. Any questions with this?
No.
Okay. Okay. Now, do you all remember using function composition? We did study if two functions are inverses, right? Now we saw that exponential functions and logarithmic functions are inverses, right? That being the case, what is that logic that needs to be obeyed by inverse functions? Using function composition. Using function composition, do you all remember? Let's say this is f of x. Let's say this is f inverse of x. What function composition of f inverse of x should be what for inverse functions? Ma, remember or you don't remember? I'll go ahead and tell you. It is just a discussion. There is no, I'm not judging or anything, but you have to let me know. The class has to be interactive. You're all not on video and I expect you to be interactive at least.
I remember.
Okay, so that is going to be x. And f inverse, the composition of f inverse and f of x is also equal to x. I'll show you now in a minute. So this is the biggest thing that needs to be obeyed algebraically. If you want to prove two functions are inverses, you have to make sure that the function composition of a function and its inverse is equal to x. What does it mean? How do you read this? Function composition. This is function composition, right? Function composition of a function and its inverse is x. What does it mean? We did go over this in algebra too, but we will go ahead. We'll go through one example in a minute. Can I erase this?
Yeah.
How about this? Okay. We are going to find out whether, okay, let's see this one. First, we'll find an inverse, okay? We'll go ahead and find the inverse of f of x equal to 10 log x base 2. F of x equal to 10 log x base 2. Let's find the inverse of this. How do we find the inverse of this? First, we write the given function. This is this, since we are reviewing algebra, I'm going to go this fast. Now I'm going to change this. Now we have to separate it for y. We have to write it for y, right? So this is going to become x by 10 equal to log y base 2. Now 2 power of x by 10 equal to 2 power of x by 10. I'm going to write it in the form of exponents. So 2 power of 2 to the power of x by 10 equal to y. So what is the inverse of this function? So basically, this is f of x means f inverse of x is 2 power of x by 10. Any questions on this? Any
No.
questions still here?
No, I understand it.
Now, how do we prove that f of f inverse of x is 1 is x is what we need to prove for inverse functions, right? Are we doing it correct? How do you check it? So now f of x is 10 log x base 2, correct? I'm only considering the left hand side of this function, only the left hand side. Now what is this f of f inverse of x? Instead of this x, I'm going to substitute f inverse of x. So when I substitute that, 2 log base 2, 2 to the power of x by 10. That's what it is, right? So what does it mean? Here, log b to the same base, that will always be this value, the exponent value, correct? So I can write this down as 10 times x by 10, which is x. Do we understand this or do you have a question on this?
Oh, I think I get it.
Okay. So similarly, f inverse of f of x, how do you find it? What is that f inverse of x function? Where is it? So here, The f inverse of x function is 2x by 10. Now, wherever there is x, right, I have to substitute f of x. I substitute 2 power of, I'm going to substitute 10 log 2x divided by 10. Wow, what is this? So this and this get cancelled. And what do you have? 2 power of log 2x. So what happens here?
The 2 and log 2 would cancel out and it would become
And
x.
it becomes x actually, yes, because it's true, because this is exponent taking log again cancels those out and it becomes x, and that's how you need to prove f inverse of f of x equal to x. So this proves that we have found out the inverses correctly. So now I would like you, based on the same thing, I would like you to check whether these are inverses. I have two functions. Just let me know whether they are inverses. I'll put it out here for you.
So for them to be inverses, they both have to equal x. Like
Uh, the
the
composition of,
the composition of the inverse and the inverse of they both have to equal x.
correct. You can just verify one. So here, these two are different functions, right? You have to prove that f of g of x is equal to x. Or as I wrote, right, f of g of x, you have to prove it equal to x. If you prove this, then they are inverses. If you can't prove this, they're not inverses. If you can't prove, I need to know what is the value of this. Can you do? Send it to me. Guys, I'm going to wait, or what am I going to do?
I'm working on the problem.
Okay, thank you for letting me know. Oh, wow. Is that what you got for f of g of x? What did you get for f of g of x? Oh, Viba, is it like that you're getting? Did you do f of g of x ma g of f of x ma, Viba?
Oh, I might have done g of f of x.
I think you did g of f of x. G of f of x, your value seems correct. Okay, let me go ahead and do this one.
Yeah.
Rohan, are you able to do? Rohan, Supraj, are you able to do? Ritik, what was f of g of x?
I'm still finding it.
I'm still working.
Okay. I'll wait, guys. Yeah, I can solve it. Yes. Let me show you both, guys. F of g of x will be what? So my main function is what? F of x. First, let me write that down. Now, instead of x, see, instead of this f of x, I'm substituting g of x. So I'll replace that x with g of x. 5 power 4 times 4 log 5x. That will become 516 log base x base 5x. That will be, how can I write this? 5 log base 5 x power 16. The thing about this 5 power log base 5, they'll cancel out each other. One is an exponent, one is a log, right? So that will become, meaning when you have things like this, b log b power log b, and then you have this number, right? That number will be the value of it. That we learned it in algebra to x power of 16. So this is f of g of x. Vibha, to clarify your problem, right? See g of f of x. That is your answer, Vibha. Here, your main function is g of x. So let me write down g of x. Now, g of x is my main function. So instead of x, I substitute f of x. Instead of x, I substitute f of x. Am I making sense, guys?
Yeah.
Nidhi, are you with me?
Yeah.
So what happens here? Again, you see the same thing. Do you see? So what happens? 4 times 4x. This is 16x. Does it make sense? So g of f of x gave you this. F of g of x gave you this. Neither gave you x. If it gives you x only, they are inverses. So these two are not inverses. Any questions for me?
No.
Okay. I feel like really giving you a problem here. Hold on. I need to get the problem, guys. Hold on. I don't have it ready. I thought you were remembering these, but that does not matter to me. Hold on. This was related to function inverses, right? Just a minute, guys. Honestly, I didn't have a problem ready on that. Hold on. Mm. How about this? Okay. Can you tell me if these two functions are inverses? You're going to find it and let me know. Are these two inverses? That's nice, Vibha. I think that's correct. Oh, good. Yes, Abhiram, that you can simplify, right? Just now I told you 5 power of log 5, you can simplify it as what? 5 power of log base 5x, right? So what does it become? That's right, Nidhi. Abhiram, you can simplify that further. Bhuvanesh, I'm not getting answers from you. Rohan, I didn't get answers from you.
Yeah, I'm simplifying it.
Yeah, if you don't know, it's okay, guys. You can just let me know. I didn't know. Can we work it out on the board? At the end of it, it needs to be fruitful for you, and you need to understand and move on. Okay, thanks, Rohan. Okay, for those of you that did it right, I can give you one more problem to find the inverse. That will tell me that you have understood whatever we have discussed. What is the inverse of this function? That's the second problem. That's right, Abhiram. Sure, I will work it out. Yes, even if one of you ask, I'll work it out. Here, what I'm saying is we are check if f of x and g of x are inverse. How to find that out? The only way to find it out algebraically, if you plot it in Desmos, it's so easy. Okay. If they are reflections on the line y equal to x, they are inverses. But for you to find it algebraically, you have to find f of g of x. What is f of g of x? Your main function is f of x. Let's write that down. Now, your main function is f of x. Instead of x, you're substituting what you have for g of x. So that becomes 5, 8 log x base 5 divided by 8. Now, in your exponent, this and this gets cancelled. You end up with 5 log x base 5. As I already told you, due to this, the value becomes x. Supraj, am I clear?
Yeah.
Okay. Now, can you all proceed with this? Ritik, Nidhi, Vibha, you got. Wait. The second one for the inverse, right? Vibha, that is incorrect, ma. But I think you know how to do, but there's some logical mistake there. Nidhi, no, not a logical mistake, but a computational error is there. Nidhi, Ritik, that seems right to me. Rohan, f of g of x you got, f of g of x, I got x, right, Rohan? The 8 got cancelled, right, Rohan? Bhuvanesh, you got the second one. G of f of x, I can check g of f of x. I don't know, Rohan. I'll check. I don't have it with me. So g of x is my main function. Instead of x, I'll substitute f of x. So 8 log base 5, 5 power of x by 8. So this one will become x by 8. Rohan, 8 still gets cancelled and it becomes x. Abhiram, the inverse is correct. Nitin, did that help you to check whether they are inverses, Nitin?
Yeah.
Is Priya's my answer right for the second one?
For the second one, yeah, Vibha, something is not correct, ma. Vibha. The second thing what you have sent is right, I think, Vibha. Second one, let me do it on the board. You should have gotten 4 by 3 log x, log x base 10. Let me see.
Oh, yeah, yeah, it's that. I just forgot to move it to the other side.
Oh, okay. Okay.
I,
With the
I, was-
second one, right, Vibha?
I just solved it wrong the first time.
Oh, okay. So here you're going to change it to x to y, y to x. For finding the inverse, that's the rule, right? Now what do you do? It's an exponent. So what can I do about it? I'm thinking. Can I take log on both sides? I do log base 10 on both sides, right? So do you see? This becomes 3 by 4y. Log base 10x equal to 3. But I need the y value, right? So multiply by 4 by 3 on both sides. Your answer y, which is f inverse of x, is 4 by 3 log base 10x. Any questions, guys? Okay, now I'm going to ask you a question. Should we solve one more of this type or should I move on?
We can move on.
Others, should we move on or we should solve more of this type inverses? Okay. Okay, I'm getting. Okay, let's move on then. Okay, now you understand that an exponential function and a logarithmic function are inverses of each other. Everything will be opposites. X-intercept will be y-intercept, y-intercept will be x-intercept, asymptote will also be asymptote of a exponential function is what? Who can tell me the asymptote of an exponential function?
Y equals 0.
Asymptote of an exponential function is what? The
Y
parent exponential function, let's say 2 power of x.
Y equals 0.
So asymptote of the logarithmic function will be x equal to 0. Makes sense? And domain of an exponential function will be? Domain of an exponential function will be?
Negative infinity comma positive infinity.
Yeah, so range of the logarithmic function will be the same. Now coming to the range of the exponential function, what it will be?
The rate, no,
0
wouldn't that range be
0
like
to infinity.
0 to infinity. So naturally the domain of the logarithmic function will be 0 to infinity. Makes sense? Okay, now I just want to discuss transformations. We'll see where we are. If we don't know, then we'll get into the intricacies of this. Otherwise, I want to move to function modeling. Okay. I know I'm a little rushing through, but at the same time, I don't want to lag a little bit as well. As long as you understand, I want to move on. How about this? What has happened here? What transformation has happened here? You think you can say? I just want you to say asymptote, domain range, and end behavior. I'll help you guys if you don't know. Asymptote, domain, range, and behavior. Let's try.
Didn't it have a reflection because you had to factor up the -1?
Correct. You have to factor the minus. Very good thing. When x has it, right, x should never be in minus. So what I'll do, I'll have to factor out the minus. That is so true. So how I would write it is minus will be outside. Minus will be outside of those two. So what happens here?
Then it would also be moved to the right 4.
Correct. Okay, let me write out the transformation I asked you. I didn't write that. Amma, let's do the translation last. Okay, before that, what is this minus?
Reflection over the y-axis, x-axis.
Y-axis,
So
y-axis, please. Here the x coordinate is negated completely. Okay, when the x coordinate negates, it's a reflection of the y-axis. When the same minus is outside, the y itself negates. So the reflection is on the x-axis.
okay.
Then write by 4. Okay, now what else? What else you can say? Anybody can
Asymptote
say
is the same.
as really? Why no?
Oh,
Asymptote cannot be the
oh
same.
wait, no.
Uh,
It's moved like 4
correct.
to, yeah.
Correct. For the parent, x equal to 0 was the asymptote. So here what happened?
It'd be x equal to 4.
Correct. So that gets you. So whatever is in the bracket gets you the asymptote. Nice. Then domain
Domain would be from 4 to infinity.
4
Not,
to
yeah,
infinity, both are bracket.
yeah. And then
Range.
range is all real numbers.
Yep. End behavior is a little tricky. What do we do? End behavior, the only problem with the end behavior is as x tends to minus in. Okay, first let's draw the graph. Let's draw the graph. Have we done the domain right? I wanted to check. Something feels wrong to me in here. Let's see. Yes, Ritik. Okay. So here, let's see this one. End behaviors, the domain seems incorrect to me. See, there is a reflection. See, this is our parent graph. If this moves to the right by 4, this is the right by 4. Okay, right mode. After that, there is a reflection on the the reflection on the y-axis. So the graph became like this, right? Asymptote is x equal to -4. Correct, guys? Does it make sense or is it not making sense? Guys, you have to let me know. What is the asymptote here? X equal to 4 or x equal to -4? Wait, let me see. Okay, first it got reflected and moved to the right by 4. Oh, okay. So here the thing is, let me go over this graph transformation once again. X will be equal to 4 will be there, but I don't think we understood it properly. So here the parent graph is this. Okay. Now the first transformation was reflection on the y-axis. Okay. That was the first transformation. And then it moved to the right by 4, 0 to 4, meaning this was 1, 2, 3, 4. So the graph became like this, right? Now, so the asymptote is correct, but is the domain correct? What happened to the domain? This is your final graph, right? What happened to the domain? Guys, what is going on? I'll also wait.
The domain would be shifted, right?
Yeah, the domain will be what, Amma?
Oh,
This is
it'll be negative infinity, comma 4.
negative infinity to 4. Range will be, range is correct. But end behavior, when you look at it, right, as x tends to minus infinity, y tends to,
Y tends as x tends to infinity, y tends to negative infinity. Right?
as x tends to
Wait,
minus
sorry.
infinity, y tends to infinity, right?
Yeah, my bad. Sorry, I was
Y
running.
tends to infinity. Now here x cannot tend to infinity. There is no infinity for x. So can I call it as 4 minus? This is 4. It is to the left side, right? As x tends to 4 minus, y tends to what?
4 minus negative infinity.
It goes to negative infinity. This is how you write down the end behavior. We'll do for one more and then I'm moving on. Okay, how about this? Let's do for this one. Minus 2 log x minus 2 base 3. Okay, let's try this one. Okay, what happened to domain, range, and behavior transformation? Please, guys, you have to let me know. Aj- Guys, you have to go ahead. You want to say that? Go ahead, guys. Guys, what's going on? Then I'll also stop, right?
Wait, I'm solving it on.
You can shout out, guys. Let us make it interactive. Bhuvanesh, Rohan, Abhiram.
Wouldn't the domain be negative infinity, comma 2?
If you're not getting it, that needs to come out too. If you know, then you have to say, sorry, Ma, Vibha, what was that?
Would the domain be negative infinity, comma 2?
The domain be negative. Is it negative infinity, comma 2, Ma, or 2, comma infinity?
Oh, it's 2,
Two
comma infinity?
comma infinity.
Oh, okay.
What was that, Ma?
2, comma infinity.
Yeah, because I am thinking the graph is going to go up to down, right? I'm thinking the graph is going to go like this, right, Ma?
Yeah.
Yep, 2 to infinity, correct. End behavior will be a little different here as x cannot tend to minus infinity. So what do I write? 2 plus, right? Y tends to infinity. X tends to, I cannot tend to plus infinity, but can I tend to minus, X can tend to plus infinity, but it cannot tend to minus infinity. X tends to infinity, what happens? Y tends to minus infinity. What are the transformations? First, I'll talk about reflection on x-axis, right by 2. See, because our parent graph was like this, when you think about it, our parent graph was like this, right? Then it was reflected on the x-axis. So the graph became like this, and then it moved by 2. Correct, it makes sense. And what is the asymptote? X equal to 2. Can I move on, guys?
Yeah.
Abhiram, are we clear? Huh?
Yeah.
Okay. How about I would like you to work on condensing as well. But I cannot finish the class then. Okay, let's try. Let's try condensing and expanding. Okay. We are going to deal with 4 properties: product property, quotient property, and power property. I plan to finish this. Okay. I plan to finish the condensing, expanding, and then go over and solve at least 2 problems in logarithmic models for you today. Not sure how many of you are okay with it, but I will try to end it as planned. Okay. So let's go over the 3 important properties now. Let me erase what I have. Product property, quotient property. Let's discuss these 2 first, or I'll write it down here. Product property says log B. So what does it mean here? So if you have log B of 6, let's say, I can write it out as any base. 3 times 2 log B log 3 base B plus log 2 base B. Do you all remember this, guys? Similarly, if I have log B x by y, what will happen? This will be log x base B minus log y base B. Do you remember all these? Do you remember all these?
Mhm.
Yeah.
Okay. Okay. Now, if I ask you log bx power k, we'll also discuss the product, the power property. Log b x power of k. I can write this out as k log x base b. Any questions here?
No.
Now, this is helpful for condensing and expanding. So let's try this. How about, shall we expand this one? Let's see whether we are able to. We'll do one in expanding and one in condensing maybe. How about this? Okay. Can we do this? What do we want to do? We are basically going to condense. Can we condense this? Can we condense this?
Yeah.
Oh wow, you all seem to be good at it already. Very nice. Okay, how about this? Okay, now this is another condensation, but it is complicated, I think. I don't know whether to do this or go. Okay, let's see. Yeah, most of you got it. How about this? Should we do this or can we keep moving, guys? Should we do this?
Wait, Auntie, I didn't log X. I meant log 3.
Oh wow. Yeah, you're supposed to condense these because they're so long, right? You're definitely supposed to condense these, Supraj. A square b power of 4, correct. And then d power of 1 by 3, correct. Divide by c cube, amma. Bhuvanesh, divided by c cube.
Oh, if I didn't see the
Did you
log
see
three.
that?
Yeah, I didn't see the log 3.
No, no worries. So these are difficult ones, but then be careful when you do. Here, you're going to condense this, right? So you can write this out as log base 3ab square, and then you have a 2 up there. So minus, I want to condense, right? Log base 3 c cube plus log base 3d power of 1 by 3. Now, all are in the same base, right? So you can write them together. Problem is, these two are minuses. So C has to go down, D and all of this can come up. So A square, B power of 4, D power of 1 by 3 by C cube. Does it make sense?
Yeah.
Yeah.
Okay. Now expansion. Expansion, and then I want to do function model, at least 2 problems. Okay, expansion. Okay, expansion seems pretty easy. Then condensing. How about this? Is the only problem we'll do in expansion, please. How do you expand? It's division, right? So you write it out as minus. So log base 10 First, let's write it out as cube root of x plus 5, and then expand minus log base 10 y square. Now bring that 2 in here, bring this 1 by 3 in here. So what happens? 1 by 3 log base 10 of x plus 5 minus log base 2 log y base 10. You all with me?
Yeah.
Okay. Coming to the change of basis, you should remember the formula, but I would like to touch upon it. Oh my gosh. So if you want to change basis, right? Where I left it, I said I'll come back to this, right? For such problems, right? We use this formula where, see, if you have a different base, right? You can bring it to log 10. Suppose, let's say you have this problem. You have to find this. Instead of this, what you can do is you can come to base 10, which you can do it in your calculator. How? Log base 10 of 25. Whatever you want to find the log, bring it to base 10. But then the base also you have to bring it to log base 10. Do you see? So this you can type it in the calculator and get the values. Does it make sense?
Yeah.
Now, how about this? Okay. Okay. I really want you to try one of these problems. One thing to remember is logarithmic functions, right? Exponential function. See, okay, let me go ahead and show this one to you. I'll give you a table, how to find out it's a logarithmic function quickly, easily. I'll give you a table, how to find it's a logarithmic function easily. When you think about your x and y values, right? Exponential function is the other way. Logarithmic function, do you see there is always a multiplication factor here for equal amounts of input difference? You see here 2, 2, 2. Do you see for every 2 difference in input, it's being multiplied by 3. So the independent variable is see, you always get a multiplier there. So you can find it. See, in case of exponential function, it happens on the y value, right? Now, in logarithmic function, it would be the other way. Now, let's find out a regression model for this one. Do you know how to perform a logarithmic regression? I would like you to write the logarithmic regression equation for this one. Do you know how to type into the TI-84 calculator? Guys, you have to let me know by this point. It's a simple regression, right? Can we do that?
And can you show it?
Sure. If you want me to show, I'll show. Hold on. I want a TI-84 calculator online. I feel like, honestly, you should also have a calculator. Otherwise, it won't work that easily. Okay. So one of you should let me know the values, guys. I'm going to share the screen with you, but I would like you to tell me the values. Let me share that TI-84 page. Tell me the values must. So I went to stat for any regression, right? Typing in XY values, right? I go to stat. What is that mark? Can you go ahead and tell me? Edit. Go ahead and tell me.
So for the x values are 2, 4, 8, and 16.
What Y values are?
The y values are 67,
Sorry, ma. Tell again.
69, 71, and 73.
Now we have to construct, as I said, a linear regression. The problem here is your TI-84 calculator can use a ln regression. Okay, so how do we do that? You have to find a regression, right? So stat, calc, go to calc, come down. Ln regression is the only option available for us. Now, do you see L1, L2? whatever in stat you had, right? The stat table, edit. When you put one L1 and L2 columns are there, right? That relates to stat, calc, go to linear regression, lawn regression, L1, L2, and then come back to store. Do you want to store this in the variable? The easiest way is how to store it. Alpha F4. See, then you press 1. That tells you it will store it in the y1 variable. Come down, calculate. You have a regression curve, right? So can one of you write down the curve? Because if I change screen, it will disappear for me. Or I can take a screenshot. Let me see. The lawn regression, I can take a screenshot. I will put it down for you. Now I have taken the lawn regression regression equation, right? So what else I wanted you to do? 65 plus 2 point. Okay. So A value is given, B value is given, Y value, the equation is as well given. So you have to substitute A, B and write down your equation. So here, let me show you how I write down my equation. Oh my gosh, what is this? Okay. So here, see, this is your logarithmic lawn regression equation. So y will be equal to 65 plus b is what? 2.89 ln x. This is your log base e regression equation. Any questions in this? Any questions in this?
No.
Now, what's the temperature? See, basically the table showed the number of students and temperature values. Okay. So here, what is the temperature? Room temperature it gave you, okay? If 2 students are there, then the temperature was 67. When 4 students are there, temperature is 69. Because of the number increase, automatically the temperature increases, right? So what will be the temperature if there are 35 students? So the values given were, can you tell me the values as well, Vibha? I can write it down for all of you.
Yeah, 1 minute. Let me find the values real quick.
2 students, 4 students.
It was 2, 4, 8, and 16, I'm pretty sure.
Uh-huh.
And then
Okay, you want me to see and write it? Okay. 8 and 16, 67, 69, 71, 73. 67, 69, 71, 73. It was a simple regression curve, but clearly tells you how to find out lawn regression. Okay. So now we have the values. Now we want to predict for 35 students, what will be the value? How do I do it? What should I do? 35 students. We already stored it in the variable, correct? We already stored it in y1, right? So it is very easy, meaning in our calculator, this was stored in y1. So function of 35 is what I need to find out. So y1 of 35 is what I need to find out and just tell the answer. You don't need to do anything. See, these are all very useful when you go to your SAT exam. You should be very good with your calculator usage. So what you can do is y1 of 35, right? So let me quit. Oh, okay. I quit here and then I go to my bars, right? So y1 of 35. Y1 is already stored there. See, 75.25. So it's so easy. Grab things like this to make it fast. If you're slow, right, what would happen is you would have to type this entire equation and substitute the value of x. Don't do all that. Okay, see what helps you better. So the answer is what? Now, if there are 35 students, the temperature will be 75.25. One last question. How about how many students are there when the temperature reaches 85 degrees? How to do that? When the temperature reaches 85 degrees, how to do that? Any thoughts? The last question is, let me write that down for you. This was question number 2. Question number 1 was the equation. Question number 3 was when temperature is 85, how many students are there? How will we calculate that?
Is
You
it
know what?
don't you if it's like you have to make that y1 and it'd be y1 or like what was it, 85 equals 65 plus 2.89 ln x.
Yeah, basically you'll substitute, right? Ma, don't do that, I would say, because see, you can substitute 85 as y1 and work out this equation as well. That is one way. 85 minus 65 is 20. So 20 divided by 2.89 is ln x, and then you find the x value. But that's not what we want, right? Easiest way is what? Here, the minimum value, let me put it out as 1. We already have the values input in the calculator, right? So x max can be, let's say we need till 85 temperature, right? So let it be like 90, and then what else? This need not be, let it be 2, and then y min can be what? Y min can be 60, y max can be, that's the temperature. Oh, y max should be 90. Number of students also can be 90, I feel, honestly. Okay, let's see whether we get it. Graph. See, we are getting the graph. But you know what? What I can do is, okay, so we have it in here. Now we have the graph. But you know what? On the plot, we need one more graph, right? See, here we need to find out the intersection. So I will write it out as 85. So it will graph both and I can find the intersection. Intersection is nowhere to be seen. So what do? I adjust more on the x. So let's see this one. 150 maybe or 200. Let's see graph. Nowhere. Oh, that's hard. Maybe 1500. Let's see. Ah, there we have. So now again, we can go to stat calc intersection. Where is that intersection? How do we go for that? How do we go for the intersection calculation? Do any of you remember? How do we calculate the intersection, guys? Do you remember or you don't?
Don't you have to go to trace
Ah, thanks. Trace.
and then we
I think this one, ma. Yeah, I have it, ma. Second and calc. So
Yeah.
intersection points automatically will come. See, first curve, no. Enter. Second curve, no. See, I see intersection is 1024. Do you see it?
Yeah.
So this is how you calculate. This is how you do regression. So when there are 1024 students, the temperature reaches 85. Nobody will have that many students. Any questions here? So the answer for the third one is 1024. Do you want to stop here or do one more problem? I'm open for either.
I think I get it.
Or others, Abhiram and all.
Yeah, I got it.
Abhiram, Bhuvanesh, Nitin, Rohan, you have to answer Nidhi.
I get
I
it.
got it.
Yeah,
Huh?
I
I
get it.
get it.
Okay, then we'll stop here. This is on logarithmic modeling, meaning if you're given a table, you can model it using your calculator.
Thank you, Auntie. Bye.
Okay,
Have a
guys.
great
See you all
day.
next week. Bye, ma'am.